Namaskar, welcome to the channel Anka Ananda Haran, that is extracting happiness from the teaching learning process of mathematics. In the previous videos, we have discussed most of the theoretical aspects of chapter 2 and chapter 3. Now onward, till chapter 3 is over, we will discuss several varieties of problems from the linear algebra and its application book of Gilbert Ram. Specifically from chapter 2 and chapter 3 we will do. But as this time I have decided to do the complete problem here online, that's why the video may be bit lengthy, but it will be more useful. And second thing, as some of the students have requested to discuss in Hindi, I will try my best to explain some of the aspects in Hindi also. In addition to English, some of the aspects I may explain in Hindi. But my request is to ignore the grammatical mistakes, specifically in terms of verbs. If I commit any mistake, please ignore it. So the first question is, which of the following subsets of RQ are actually subspaces? What about my first question? It is V is equal to B1, B2, B3 belonging to RQ such that B1 is equal to 0. It is a vector space or not? So I have to verify three conditions. V is non-empty and V is non-empty and V contains 0 vector, and V is closed under vector addition and scalar multiplication. So first condition I will verify, that is 0 vector. So here 0 vector is having first component 0. So all the elements of this vector space, or this set of vectors V is set of all the vectors whose first component is 0. So here 0 is a vector whose first component is 0, hence it belongs to V. So that implies V is not empty. It has some vectors inside it. So it is one of the first property. Next property we will go for, let U is equal to 0, U2, U3. Clearly its first component is also 0. It belongs to RQ. It belongs to V. And similarly, W is equal to 0, W2, W3. It is also having its first component 0, hence this is an element of V. Now what about U plus W? Its first component 0, U2 plus W2, U3 plus W3. So in the resultant vector also the first component is 0. Hence it belongs to V. Now what we have done, we have selected any two arbitrary vectors of V and we have added them, and the resultant is found in V. Hence V is closed under vector addition. Similarly, C into W is equal to 0, CW2, CW3. That is scalar multiple of any arbitrary scalar multiple of any vector W is an element of V again, because its first component is also 0. So this implies V is closed under scalar multiplication. So we have got all the three properties, that is property 1, it is property 2, it is property 3. It is property 2. It is property 3. So from properties 1 to 3, what we conclude? What we conclude? So here we conclude that V is a subspace of RQ. This we concluded. So here one observation is, if to prove V is a subspace of RQ, we have to prove for generalized element, not any particular example. We have to prove it through general elements. But to prove that it is not a vector space, or to claim that it is not a vector space, just one counter example is sufficient. So here, question number 2, B bit, what it is telling? So here, V is equal to B1, B2, B3, such that and a W already that we have written V na, such that B1 is equal to 1. That means its each element has first component 1. Now you take any arbitrary any element. First of all, it is not having zero vector. So if any set of vectors is not having zero vector, then it cannot be a vector space. So W is not a vector space. As 0, 0, 0 is not an element of W, therefore W is not a vector space. But we have to justify through the other conditions. How it can be justified? Suppose I have vector 1, 2, 3. Naturally, it belongs to W because its first component is 1. Similarly, 1, 5, 7. This is also an element which belonging to W. But suppose its name is X, its name is Y. So what about X plus Y? This is equal to 2, 7, 10. Is it an element of V? This is not an element of W. So what can we conclude? W is not closed under scalar multiplication. So what we get? Here scalar multiplication I have not proved. It is not closed under vector addition. This part. This is not closed under vector addition. And scalar multiplication W is not closed under scalar multiplication since 5 into Y is equal to how much? 5, 25 and 35 is not an element of W. So because of this, W is not closed under scalar multiplication, and because of these two reasons, W is not closed under vector addition. Hence W is not a subspace. So W is not a subspace. So to prove that not a subspace, just counterexample is sufficient. To prove it is a vector space, we have to go for the complete proof. For general elements, not for particular element. So here B2, B3 is equal to 0. Okay, so let us prove that part. So what it is given? W is equal to B1, B2, B3 belonging to R cube such that B2, B3 is equal to 0. Now my claim is it is not a vector space. So as it is not a vector space, I just require a counterexample. Suppose 2, 3, 0. This is an example of W because why it is belonging to W, this into this is 0. Similarly, 2, 0, 3. Sorry, it is 3. 2, 0, 3. What is it? This also belongs to W. Suppose its name is X. Suppose its name is Y. What is X plus Y? This is equal to 4, 3, 3. Now what about their product? This product is this and this is not giving me 0. So it is not an element of W. So what we got? X is an element of W, Y is an element of W, but X plus Y is not an element of W. That implies W is not, it is an closed under vector addition. So if it is not closed under vector addition, can it be a subspace? Which implies W is not a subspace of R cube. So with this, today we will conclude. Thanks for watching. In the next video, we will do rest of the problems.